Hello students, today we are going to discuss about the chemical properties of acids. Let us start with the first chemical property. Acids produce hydrogen ions and respective anions in aqueous solution. We know that when acids are dissolved in water, they furnish hydrogen cations and their respective anions. You can see here hydrochloric acid forms hydrogen cations and chloride anions in water. But in all the acidic solution, H plus ions produced are not stable, so they always interact with water molecules to form hydronium ions. So whenever we say that acidic solution consisting of H plus ions, they are present in the form of hydronium ions. Let us move to the second chemical property. Acids react with metals to form respective salt with the liberation of hydrogen gas. You can see from the examples given here, zinc reacts with sulfuric acid to form zinc sulfate with the liberation of hydrogen gas. Also, it reacts with hydrochloric acid to form zinc chloride with the liberation of hydrogen gas. Also, magnesium reacts with hydrochloric acid to form magnesium chloride, and iron reacts with hydrochloric acid to form iron chloride. In all these reactions, you can observe that these metals are displacing hydrogen from the acidic solution. So, these reactions are also called as displacement reaction. In the fifth example, you can observe the copper is not going to displace hydrogen from the dilute acid, dilute hydrochloric acid. There is no reaction here. Why? Because this shows that the order of reactivity of these metals towards the same acid, that is hydrochloric acid, is not same. The order of reactivity of above metals based on the experimental data was found to be magnesium reacts more vigorously than zinc, which reacts more vigorously than iron. But in the fifth reaction, the reaction is not going to take place. Means the copper is not going to displace hydrogen from the dilute acid. So, this shows that all the metals do not react with the same acid with the same vigor, which is due to the different reactivity of metals towards acid. You can also see some other examples like magnesium reacts with sulfuric acid to form magnesium sulfate. Also, aluminium reacts with sulfuric acid to form aluminium sulfate salt. When it comes to nitric acid, it reacts only with manganese and magnesium to form manganese nitrate and magnesium nitrate. You can see the reactions here. So, based on these experimental data of displacement reactions, a reactivity series has been developed which shows a list of metals arranged in the decreasing order of their activities. You can see that from the given picture. The most reactive metals are placed at the top of the reactivity series, and the metals of moderate activities are present in the middle of the activity series, and the least reactive metals are present at the bottom of the reactivity series. You can see here the metals which are placed above the hydrogen are more active than hydrogen. They are more reactive, so they can displace hydrogen from the acids. But the metals which are present below the hydrogen cannot displace hydrogen from their acidic solution. Now you might have understood why copper has not displaced hydrogen from hydrochloric acid, because it is less reactive than hydrogen. Next, let us study the reaction of acids with metal carbonates and metal hydrogen carbonates. When acids react with metal carbonates and metal hydrogen carbonates, we get salt, water, and there is a liberation of carbon dioxide. You can see here, sodium carbonate reacts with hydrochloric acid to form sodium chloride, that is salt, water and carbon dioxide. How does this reaction proceed? The aqueous solution of hydrochloric acid has hydrogen cations and chloride anions, and sodium carbonate also produces sodium cations and carbonate anions. In this reaction, actually there is a exchange of ions between these two reactants. The sodium cation of sodium carbonate interacts with chloride anion of hydrochloric acid to form sodium chloride, and hydrogen cation of the hydrochloric acid interacts with carbonate anion to form H2CO3, but it is unstable. It decomposes to produce finally water and carbon dioxide. In the same way, sodium hydrogen carbonate, it is a metal hydrogen carbonate. It reacts with hydrochloric acid to form salt, water and carbon dioxide. The salt formed here is sodium chloride. Here also the sodium replaces hydrogen from acid to form sodium chloride. Now the hydrogen cation of the hydrochloric acid reacts with hydrogen carbonate anion to form H2CO3. In this case also, as H2CO3 is unstable, it decomposes to form water and carbon dioxide. You can see few more examples. Calcium carbonates react with hydrochloric acid to form calcium chloride, water and carbon dioxide, and sodium carbonate reacts with sulfuric acid to form sodium sulfate, water and carbon dioxide. In this way, the acids react with metal carbonates as well as metal hydrogen carbonate to form salt, water and carbon dioxide. In the previous examples, you have learnt that there is a liberation of hydrogen gas when acids react with metals, and there is a liberation of carbon dioxide gas when acids react with metal hydrogen carbonates as well as metal carbonates. But these gases, that is carbon dioxide gas and hydrogen gas, these are colorless. Also, these are not having any peculiar smell. So, how do we test the presence of these gases once the reaction is completed? Let us study it. There is a particular test for carbon dioxide, that is lime water test. In the lime water test, we take lime water. It is a solution of calcium hydroxide in water. It is a dilute solution of calcium hydroxide in water. When the carbon dioxide gas is passed through the lime water, it combines with calcium hydroxide to form white calcium carbonate precipitate. So, the lime water will turn milky. So, once you get carbon dioxide gas and you pass it through the lime water, it will turn the solution milky because of formation of calcium carbonate precipitate. So once the lime water turns milky, it will shows that there is a presence of carbon dioxide gas. Also, when you pass excess of carbon dioxide through the lime water, what happens is the excess carbon dioxide will react with calcium carbonate to form calcium hydrogen carbonate, which is soluble in water. Again the reaction, again the lime water will become clear. So what you have to understand is, if you want to check for the presence of carbon dioxide gas, you have to pass the gas, liberated gas, through the lime water, and if it turns milky, then there is a presence of carbon dioxide gas. Then how do we test for the presence of hydrogen gas? For testing the presence of hydrogen gas, just bring a burning candle near the reaction mixture. If the liberated gas burns with pop sound, then the gas formed is hydrogen. This test is called as pop test. You can see the representation of the pop sound in the given picture. Let us move to the next chemical property, that is reactions of acids with bases. When acids and bases react with each other, they form salt and water. In these reactions, the acids and bases neutralize each other. Therefore, these reactions are also called as neutralization reactions. In the example, sodium hydroxide reacts with hydrochloric acid to form salt, sodium chloride and water. The aqueous solution of sodium hydroxide has sodium cations and OH minus anions, and the aqueous solution of hydrochloric acid has hydrogen cations and chloride anions. The sodium cations interact with chloride anion to form sodium chloride. The hydrogen ion interact with hydroxyl anion to form water. In the same way, potassium hydroxide reacts with sulfuric acid to form potassium sulfate and water. Potassium sulfate is a salt. And copper hydroxide reacts with sulfuric acid to form copper sulfate, that is salt and water. We can define neutralization reaction as the reaction between an acid and a base to form salt and water. Now let us see the reaction of acids with metal oxides. When acids react with metal oxide, they form salts and water. You can see here sodium oxide is a metallic oxide. It reacts with hydrochloric acid to form salt, sodium chloride and water. Then copper oxide is also a metallic oxide. It reacts with sulfuric acid to form copper sulfate and water. Then calcium oxide reacts with hydrochloric acid to form calcium chloride and water. In all these reactions, you can see that the acids react with metal oxide to form salt and water. These reactions are similar to the reaction between an acid and a base, which forms salt and water. So, we can see here that metallic oxide behaves as bases. Metallic oxides behaves as bases.